All right, Algebra 2, we're going to be doing multiplying and dividing rational expressions. Remember, rational comes from ratio, which just means fractions. These look very scary, and they can get ridiculous, but if you do the little shortcuts first, then it's not that bad. Y'all know my thing on shortcuts. I hate shortcuts. I hate tricks. I think you should just learn the rules and suffer through it like the rest of us. But these aren't really tricks. This is actually number sense. So before I even do example 1, what I'm going to do is I'm going to show you something that kind of matters. So you can write this down or not on your blank pages, or you can just watch this. So what I'm going to do is I'm going to start out with a, what's it called? One second. I'm going to make this little fraction problem up, and I want y'all to pay attention to it. So I did this in class, where if I had 4 over 5 times 5 over 4, and we just followed the basic rule of fractions, which is multiplying goes straight across, meaning numerator to numerator, denominator to denominator. 4 times 5 is 20, and then 5 times 4 is 20, and if you were to simplify that, it would come out to 1. Now, why am I showing you this? Because there's actually something else you can do before you get into that. So watch how I am going to now solve this one using a little different technique. So I notice right here, there's a multiplication sign here. These fraction bars represent division. Look what I can do. You see this 4 here and this 4 here? I can actually simplify those out before I do anything. I can divide those out. And 4 divided by 4 breaks down to 1. So I end up with a 1 where I divided out the 4s. Check out the 5s though. I can do the same exact thing here, and now I'm going to end up with 1s here. Now what's the rules for fractions? Straight across, doesn't change. But now instead of multiplying bigger numbers, I'm just multiplying 1 times 1, which is 1, and then 1 times 1 on the denominator, which is also 1. So do you see the difference? On the top one, you can get to the right answer, but you're going to end up dealing with bigger numbers. Whereas the method I just showed you down here, you're going to deal with smaller numbers. So let's go to example 1. Y'all know how I feel about all these written out rules. Like, these rules aren't very helpful for teaching. They're good for using as a reference chart. So ignore the rules right now and just watch my work, and then you can go back and read the rules yourself for your reference. Okay. This, believe it or not, these aren't actually new skills. So all of you who are panicking thinking this is new, it's not. We're dealing with GCFs, we're dealing with multiplication, we're dealing with division. It's the same stuff over and over. So I'm going to go ahead and I'm going to start, how am I going to do this one? I'm going to start by simplifying my numbers the best that I can. So the first one I'm going to do, I see that 2 can basically go into every single number. So I'm going to basically, as I simplify, I'm going to set up, oh, where did that come from? Great, ignore that. I am going to basically, I'm going to start by rewriting this. Like, how do I want to do this? What's the best way for y'all? What's the best way for me? I'm going to start by rewriting this. First thing I'm going to do is I'm going to divide everything by 2. Do you see how all these numbers can divide by 2? So that 8 can go down to 4. That 14 can go down to 7. This 26 can go down to 13, and then this 12 can go down to 6. So I saw that these numbers were all even. I wanted to shrink them, so I divided by 2 everywhere, and that's where I got that. So that becomes simplified, but check it out. The 4 and the 6, that can still be simplified. Those are still even, so I'm going to divide the 4 and the 6 only by 2. So when I do that, I'm going to end up with the 2 here, and I'm going to end up with the 3 here. When you do these dividing outs, you have to be able to divide something on the numerator and something on the denominator. That's how it works. So you can see in this case how I'm able to basically get my numbers down perfectly reduced. So I'm going to go over here and I'm going to set up my final numbers here. Y'all know how I feel about setting up the skeletons. Get your skeletons set up. And then I'm going to go ahead and write the numbers here. Now, this is kind of up to you how you want to do this. I think solving the letters in one big swoop is easier because we're not dealing with big numbers here than it is trying to, reduce here, reduce there, etc. So I'm going to go ahead and keep my letters exactly the same for now. Some of you probably can deduce on your own how to simplify them before we get going, but the rest of you, just do what I do. This is the easiest method. Reduce the big numbers first, and then just worry about your variables last. So I'm going to do my numbers straight across. This means multiplication. For everyone who's going to call this a dot, it is not. It is multiplication. 2 times 7 is 14. X third times Y fourth, y'all, they are different bases. This is an X, this is a Y. So we don't combine the X's and Y's. They're just going to stay across like that. And then on this one, 13 times 3 is 39. And then you'll notice I have a XY down here and an X squared there. So remember, when there's no exponent, there's a 1 there. So X squared times, X to the 1 times X squared gives you X cubed. Remember the rule, you have to add them when you're multiplying it. And then I'm going to move my Y here. So, looks a little junky. I know my handwriting's not perfect, but check out what happens. I'm going to switch this purple real quick. Check out what happens on this X third. This is saying 14X to the third over Y fourth, etc., etc. This X third crosses out. If you do 3 minus 3, you're going to end up with 0, which means you've got 0 X's left. Pay attention to the Y's. There is technically a 1 in the exponent form. So what's going to happen is you're going to end up with 4 minus 1 for your Y's, which is then going to be put onto your numerator, which is the top. And then that's it. That's where this goes. So that looks like a lot, but for those who are freaking out, I'm going to say it one more time. With this Y, I did 4 minus 1. After doing that, those are the rules we learned in Unit 7. You place it in the numerator. And this looks good to go. This looks really good to go, actually. I think we're done. So we simplified that. I'm going to consider this the main lecture, along with the example. The other stuff I'm going to kind of blow through relatively quickly. But this is the end of video 1.